Hi guys, welcome to the final unit. This unit is on, it's kind of like a statistics probability unit. It's not fully statistics, but it's some things that you'll use later on in maybe some other classes and maybe you'll see in college. So this unit does not have a test on it because we don't have enough time to cover everything we're supposed to cover. So we will be taking a quiz next Tuesday. So let's go on to page 1 and check out what we're going to be doing here. Now, at any time, if you guys need to stop the video and replay it, please go ahead and do so, as I am just going to flow right through it as if you're not here at all. So if you need to pause the video, please feel free to do that at any time. So we're going to start with measures of central tendency, which are things that you have seen before. So mean, median, and mode. Mean has another symbol. It's called X bar. It is the average of the data that you have. Median will be the middle. The middle value. Once the pieces of data are in order from least to greatest. So in order to find the median, your values need to be in least to greatest. However, most of what we're going to do is going to be in a calculator, so the calculator can find the median for you. And the mode is the most often occurring piece or pieces of data, because you can have more than one mode in a set of data. However, if each data piece only shows up one time, then you have no mode at all. So in order for it to be a mode, it has to show up more than once. So here is the data set that we are going to be using, and I'm going to show you how to use our calculator to be able to come up with the mean and the median. It won't do the mode, but we can do the mean and the median. So what we're going to do is we're going to go into stat, that's that red button, stat, and we're going to use that edit, the very first thing that's there. So we'll just go ahead and enter that. And here, it allows us to put in our data. So you put each piece of data in separately. So once you hit 58, you hit the enter button, 53, enter, 59, enter, 51, enter, 46, 35, 51, 58, and 60. All right, now what I would highly suggest you do is make sure you count how many pieces of data you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 pieces of data there. The idea is that when you are looking at your calculator, that you also have 9 pieces of data, so that you just make sure you haven't skipped anything or put anything in twice. Once you verify that you have the data in the calculator, we can go back to stat. Now we want to calculate, so we move over to the right, and we're just doing this one var stats. It's one variable statistics. So now we can just hit enter. And this list, all we have to do is just enter through this. This is good. And it'll give us some data. So, and you can scroll down and it'll just keep like going. You can go back and forth, up and down to see whatever it is that you need. So the question, like now that we have our data set and our information, this question is asking for the mean, the median, and the mode. So let's see what we got. Oh, green. All right, back to the calculator. I showed you that mean is X bar. So if you take a look at the top of the list of data, you have 52.3. So 52.3 is our X bar. That's all. That means that is our mean. That is the average of the data. For median, we need to scroll down. Now let's see. Right there at the bottom of the screen, you'll see MED. MED down there at the bottom is going to be our median. So when we list this data from the least to the greatest, the 53 would be in the middle of that set of data. So 53. Like that 5. 53. And now for the mode, we're just going to have to look at our data and see, does anything occur more than once? So 58, there's two 58, so there's a 58, there's a 58. 53, there are no other 53s, there are no other 59s, there are two 51s, there's no other 46, 35, or 60, so we have two modes, 58, comma, 51. So we had two modes for that piece of data. And that is how you're going to go through using your calculator, doing the measures of central tendency. All right, so let's move on. At the bottom of page 1, you'll see the mean absolute deviation, which we're just going to skip because it's a little complicated and it'd be just better to do if I'm with you. So we're just going to skip over the mean absolute deviation and head on to page 2, where we're going to look at some variance, standard deviation. So variance, I'm going to tell you a couple things about variance. Variance is a measure of spread. How far is it spread apart? Okay, so that's what variance means. So the bigger your variance, the further spread apart it is. Now, how do you get the variance? It is the standard deviation squared. And the symbol, I think that's right. The symbol tells you that. So you can take the standard deviation, whatever that number is, you can square it. And so that's what this is telling you here. So really these two should be like backwards. So standard deviation should come first, and then we do variance. So please note that here is the symbol for standard deviation. So to get the variance, you're just going to take the standard deviation number and you're going to square it. So the formulas that are over on the right, you guys don't have to pay any attention to those because a calculator is going to do all our work for us. So again, standard deviation is just a measure of how far things are spread apart. So we're just going to copy that and we're going to clone it and put that down here because that's exactly what standard deviation is. So we'll do this too. Okay. So actually, let me back up and not do that. Let's do something else. Let's call standard deviation something else. Because standard deviation is actually how far each piece of data, if I spelled piece wrong, I'm sorry, is from the mean. So it's the average. It's the average of how far each piece of data is from the mean. So when you go back and you see this data, the mean is 52.3. So maybe the standard deviation is like, I don't know, I'm making this up, 2.4. So that means that each piece of data is roughly 2.4 units away from 52.3. So that was all made up, but I was just kind of trying to give you some context as to what we're doing. So when we have a lower standard deviation, what color are we on? We're on green. When we have a lower standard deviation, it means that the data is really close together. And if you have a larger standard deviation, that means the data is really spread apart. Okay, so a small standard deviation means that the data is close together, and the larger it is, the more spread out it is. All right, at the bottom of page 2, you'll see this calculator steps. Okay, and we've done a little bit of this already. I've shown you how to enter the data and hit stat. And then here we go over to calculate the variable stats and we hit enter. And then we're just going to scroll down to find these pieces of information. So this is something we did back with mean and median. So we're going to do those steps again here for variance and standard deviation. So here is the data set that we had earlier. So we have, right now, if you remember, oh, wrong one, we still have that data in our calculator from earlier. So there's like a couple of ways you can deal with the data. If you come down here to number 4, it says clear list. The list that you want is list 1, it's blue, it's second 1. So that'll clear your list. Another way to do that, I'll show you another way to do that in a minute. So we have a new set of data here for problem number 6. So you notice my data is gone. So for number 6, we have a new set of data. So let's put that data in. We have 3, enter 4, 7, 8, 11, 12, 12, 15, 19. And the nice thing about that data is it's all in order. All right, so this says we have 9 pieces of data. So just to check, let's see what we got. How many pieces of data? You go away. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that matches. Our calculator matches what we put into it. So it's 9 pieces of data. Okay, so what we've done is we have put the data in. We've done this right here. We're going to hit stat next. So we go back to stat. We're going to over to the right, go to calculate, and just choose the number 1 var, the 1 var stat. So just hit enter at that point. And then we can hit enter through here to calculate our data. And then, so this 4.86 number. So I'll cut that out and I'll show you where it is. So let's take this whole screen and we'll cut it and we'll put it on this piece of paper, put it on this current page. So I'm going to squeeze this down and get it into here. So this symbol that's right here, this 4.86 number right there, that is our standard deviation. That's what this is right here. That's our symbol for standard deviation. So we found our little theta number. It's that's 4. We'll call it 4.9. Okay. So our standard deviation is 4.9. Now to get the variance, we're going to take 4.9 and we're going to square it. So we took the standard deviation, we took this number that's here now, and we're going to square it, and that gives us our variance. So I'll go back to the calculator. There's no way to choose this stuff. Okay, you just have to type it back in. So at this point, it's okay to quit and get out of there. We use 4.9. We're going to square it, hit enter, and you can't see the whole thing. So 24.01 is our variance. 24.01 is our variance. 24.01 is our variance. All right, so let me do that again real quick with problem number 7 so that you can see another one. I told you I would show you how to clear your data. If you go back to your list, right here, list 1, what you can do is you can scroll up, hit the clear button. Nothing looks like it's done, but once you come down, everything is gone. Please don't hit the delete button. The delete button gets rid of the list altogether and it messes up the calculator. All right, so for problem number 7, we're going to put this data in real quick. 52, 47, 60, 55, 58, 53, 59, 60, 63. All right, so I have 9 pieces of data. Count it real quick. 1, 2, 3, 4, 5, 6, 7, 8. Wait, hang on a second. See, seems like I may have too much data. So see, I have this 5. This was not intentional. It's just a common mistake that happens. This 5 is a mistake. You can hit delete, and it will delete it, but I also deleted the 63, so make sure that you have the right pieces of data in there. There are 8 pieces of data. We have it. Now that we have our data in, we're going to go back to stat, calculate, enter, enter your way through here. It gives you your data. That 4.807 is going to be our standard deviation. It's almost the same as it was last time. So we're going to have 4.8. 4.8. To get our variance, 4.8. We're going to square that number. We're going to come up with 23.04. 23.04 is your variance. All right, guys, so let's move on to page 3, and we look at data distribution. You see 3 graphs at the top of the page. Those 3 graphs represent skewed left data, because you'll see a large amount of data over here on the left. In the middle, you have skewed right data, because you have most of your data is over here on the right-hand side. And then the third graph is what we call normal, which brings us right into this right here, the normal distribution. Normal distribution is going to be a symmetrical, bell-shaped curve that's defined by the mean, it's supposed to be yellow. Keep going. Wanted that to be a different color. The mean and the standard deviation, which we talked about just a few minutes ago. The area under the curve represents 100% of the data, with the total area equaling 1. Which brings us to the empirical rule, where it says that 68% of the data will fall within 1 standard deviation of the mean. I will show you what that means in just a moment. Just go with the numbers. 95% of the data falls within 2 standard deviations of the mean, and approximately 99.7% of the data falls within 3 standard deviations of the mean. So here we have this bell-shaped curve down at the bottom, and I'm going to show you where the 68, 95, and 99.7% of the data, what that means. So here in the middle, you've got the mean. Now, I've shown you that that is typically going to be called X bar, so it's the same thing. On the right here, you have 1 positive standard deviation and 1 negative standard deviation. So when you look at these areas of the curve, 68% of the data falls right in that area of the curve. And then from the second standard deviation to the other second standard deviation, you get 95% of the data. So that includes the 68%. So these 4 zones right here add up to be 95%. And then the final one, from the third standard deviation to the third standard deviation, you get 99.7% of the data, which includes all of the other ones as well. So that's where the 68, 95, 99.7 come in. All right, so let's go look at an example of what type of problem we're going to be doing with this normal distribution and empirical rule. So example number 1 says draw and label the normal distribution curves and answer the questions. So here's what I want you to do, because these are the numbers that are most important to us when doing this. From the previous screen, we have the 68, 95, 99.7. So what happens is this area gets split in half. So here's the numbers you need on this curve right here. So what I need you to do is put 34% in this area of the curve, because that totals to be 68%, and so that's what each one of those little sections represents. Moving out from each one of those is 13 0.5%. And I'm going to not put the percent because it's just getting tight. Okay? But they do represent a percent. Moving out from there, we're going to put 2.35 in the next section. 2.35. It's a 5. I'll rewrite that. 2.35. And in the final itty-bitty sections on the farthest end, right here, is 0.15. These are the percents in each of the sections of the curve. So those numbers come directly from the empirical rule. This right here, the 68, the 95, and the 97. Those numbers that you just wrote down come from, whoops, too far, it's not what I meant to do, I apologize. Come directly from the empirical rule. So 0.15. All right, so those are crucial to answering the questions. Here's how we set up each individual problem. In the problem, we're looking for the mean, and it'll tell you the mean is 178 pounds. The mean goes in the middle of the bell curve. So 178 goes right there in the middle. 178. 178. Now, this section right here represents one standard deviation. So in the problem, it's going to give you a standard deviation. And that is 8. So standard deviation is 8 pounds. Now, to get the value, let me get rid of this. We are going to add a standard deviation. So I'm going to do this in a different color. We're going to add plus 8 to get the next value. So 178 plus 8 should be 186. So that's the next value on the normal curve, 186. And then we add 8 again, plus 8. And so we continue to add a standard deviation as we move out to the right. So 186 plus 8 will be 194. So this is 194. And we do it one more time because we have a third standard deviation. So we add again plus 8. Somebody's going to ask me, why are you adding 8? Because the standard deviation is 8. And so that's one standard deviation, two standard deviations, 3 standard deviations away from the mean. So this final mark will be 202 on the right-hand side. So this is 202. To finish off the left-hand side of the normal curve, you're going to subtract. So you're going to come back this way and you're going to subtract. You're going to minus 8, minus 8, minus 8 to get those values on the normal curve. So 178 minus 8 is 170. 170 minus 8 is 162. And 162 minus 8 is 154. Now, reminder, you're welcome to go back and rewind this video as much as you need to try to understand the problem. All right, so we have 4 questions, A, B, C, and D, which we're going to answer based on this curve. It asks, what percent is between 178 and 194? So on our curve, we look for 178, which is right here. There's 178, and then 194 is right there. So we're going to add up the numbers that are in that highlighted section between 178 and 194. So just to have a little bit of space down here at the bottom, so we would take it's not the color I wanted. So it's this 34% and this 13.5%. So it's 34 plus 13.5 equals 47.5%. So that's the answer to the A problem. Now, as I continue to do problems, I'm going to get rid of information that's not relevant for that problem. And get rid of this too. So this gets us back to the normal curve where we just have the values. On the B problem, it says weighs at most 170 pounds. So now they're saying 170 is the biggest weight that they want. So they want all of the percentages that are here. So let's make that, we want all of these percentages now. And those percentages, come on, give me a pen. Those percentages are 13.5 plus 2.35 and 0.15. So we add those together. 13 and 2 makes 15.85. So this will be 16% exactly. So moving to the C problem, get rid of all of that, because that was only relevant for the B problem. The C problem wants less than 162 pounds. So where's 162? Wants less than it. So 162 is right here. So that's going to be 0.15 plus 2.35. And so that's just going to be 2.5%. Okay, and to finish this up, the D problem, how many players weighed between 170 and 186? So here's 170, here's 186. So we want the data that's in here. So that's 234s. So that's nope, don't want yellow. 34 plus 34 is 68%. Okay, here's another example. So problem number 2 on page 4. What we want is we want to make sure that you have these values. So it's 34, 34, 13.5, 2.35, 0.15, 13.5, 2.35, and 0.15. Okay, so then we find the mean. What's the mean? The mean here is 82. 82 goes in the middle of the chart, 82 right there. Then we find the standard deviation of 5. Okay, so we're going to go up 5 and down 5. So we're going to add 5 to 82 and go 87, add 5, 92, add 5, 97. So then we're going to subtract 5. That's 77, 72, and 67. So now our chart is set up and ready to answer the questions. So what percent of the scores are between 72 and 87? So here's 72, 87. So we find 72 and we find 87 and we add up the percentages that are in the middle. So those would be 13.5 plus 34 plus 34 would be 68 plus 13.5, which should be 81.5%. Start a new problem. What is the probability that the score is greater than 77? So greater than 77, here is 77. So you take all of the percentages that are right here and you add them up. Or you could do it the reverse. The numbers on the left are 16 and you could subtract that from 100. You could do it that way. But we'll take 34 plus 34 plus 13.5, 2.35, and 0.15, which should be 84%. Again, don't forget, you can rewind until you figured out what you need. What's probably the score is less than 82 or greater than 92. So now we've got a couple of sections we're looking at. Less than 82, so that's all of these numbers, or greater than 92. So now we have to take these numbers as well. So 0.15 plus 2.35 plus 13.5 plus 34, which will be 50% because that's the left-hand side of the curve, plus 2.35 and the 0.15 at the end. So that's 50% on the left and 2.5% on the right will be 52. It's 52.5%. I just got that number off. 52.5%. I can't get the percent on there. About how many students scored outside 2 standard deviations? Okay, so now they want us to do a little calculator. So about how many students scored outside 2 standard deviations of the mean? So outside 2 standard deviations, so here's the second standard deviation, second standard deviation, second standard deviation. So they're wanting, this is 2.5%, this is 2.5%. So together, those 2.5% represent 5% of 120 students. So we get to multiply that together. When you do percent, just like we did with the word problems in the logarithms, we want to make sure that 5% turns into a decimal. So 0.05, see, do I have my calculator up? I do. Clear? 0.05 times 120 is about 6 students. So there's another example for you guys. Good luck. Have a great day.